right, we're here with Dr. Harrison Schmitt, Lunar Module Pilot on Apollo 17, and the only geologist to walk on the moon. Dr. Schmitt received a BS in geology from the California Institute of Technology, studied geology at the University of Oslo as a Fulbright scholar, and received a PhD in geology from Harvard University. He later served as a U.S. Senator from the state of New Mexico, is an adjunct professor from the University of Wisconsin-Madison, and is author of the book, Return to the Moon, Exploration, Enterprise, and Energy in the Human Settlement of Space. Dr. Schmitt, on behalf of the Cosmosphere, it's an honor to be with you today, and thanks so much for your time.
Well, it's great, and my pleasure to be with them again.
Well, let's start at the beginning. We're putting together a series of questions for learners of different ages. And the first, I think, a curiosity on a lot of folks' minds, what first inspired you to get involved in space exploration?
Well, I had been aware of a few of the things that were going on in space because of the timing of my education at Caltech. The missile industry had started and things like that. People were building rockets. And then when I was a Fulbright student in Norway in 1958, the first artificial satellite of the Earth, Sputnik 1, was launched. And that not only got my attention, but I realized very quickly that it got the attention of the international students there at the University of Oslo. And that caused me to start to pay far more attention to what was going on in space.
Thank you for that. And as you went through that phase of becoming interested, were there particular habits that you had developed as a young learner that enabled you to be successful when you were going through school?
Well, I think that the main thing was that working with my father and mother and on various things, my father was a geologist as well, and I was his field assistant during summers. I learned that you've got to work hard and you have to concentrate on what you're doing to get it right. And I think that sort of type of work ethic has continued throughout my life.
That's great advice, and thank you for that. The idea of working hard to achieve your goals. And I was curious, flipping to the topic of skills, so a number of young learners are probably learning what skills they might need to acquire to follow in the footsteps of someone like you. Are there particular skills in today's day and age that people need to focus on?
Well, I think anytime you want to be involved with the space program, whether it's as an active astronaut or a mission controller or an engineer or what have you, getting as broad an education as possible is important. That particularly includes mathematics. It should also include history. You need to be able to learn what other people have learned throughout time as a result of their experiences. Also, for an astronaut education, I think a combination of a good basic science education and a good basic engineering education is very important. I, of course, went into the space program primarily as a trained geologist, field geologist in particular, and I sort of read engineering. That is, I experienced engineering first by going to pilot training and having to learn about aircraft, and secondly, just by assimilation of the experiences of my colleagues in Mission Control Center and elsewhere at the Johnson's then Manned Spacecraft Center.
Thank you for that. So looking at how that developed with the importance of history, geology, math, and science, was wondering, as you develop all of these achievements, for you in school, what was your greatest personal achievement?
Well, I guess the first major achievement was getting my PhD, completing a thesis that seemed to make some sense, having been based on field work that I did in Norway through a couple of years. That's sort of the thing that I was aiming towards. I had not yet thought about going into the astronaut program because nobody had asked scientists to apply. But it was about a year after I received my PhD, in fact, it was less than a year, more like 6 months, that NASA and the National Academy of Sciences asked for volunteers for the first group of scientists and engineering astronauts.
Fascinating. So looking at the importance of education, that's a common thread, to continue to pursue education as you're pursuing goals. And now to pivot to the audience at the Cosmosphere and the Lunar Trek Camp, want to talk about the moon, of course. A major element of the Cosmosphere's mission Lunar Trek involves landing humans on the moon to support future habitation through successful lunar development. And part of this experience includes learning about the moon's landscape and geology. So to beginning at the beginning, why is it important to understand the early history of the Earth and how the moon was formed?
Well, the moon is our library in space. It tells us what a terrestrial planet like the Earth was experiencing very early in its history. The moon's history really sort of stops at about 3 billion years ago. Clearly other things were happening, impacts, small impacts and things like that. But most of what happened on the moon was the period of time that we least understand here on Earth. And that is a period in which life had its origins. And knowing what the environment, the space environment in the vicinity of the Earth was when life began is a very important scientific endeavor. And it's occupied people throughout the centuries, really almost. But it is particularly relevant now because the moon tells us, for example, that the early history of the Earth, much like the moon, was a concentrated period of impacts of objects coming from outer space. And those objects, when they impact a body like the Earth or the moon, create a great deal of rock debris. And on the Earth, that rock debris was exposed to water. And when that happens, that debris changes very quickly to clay. And there are some very strong indications that clay provided, it's a sheet structure mineral that a lot of people are familiar with. It's used, for example, as a catalyst in the petrochemical industry on some occasions. But clay can provide a template for organizing organic molecules. And it may well be that that's really what allowed the organic molecules that were coming from outer space and being created possibly by impacts on Earth, but allowed those molecules to get organized and ultimately to self-replicate. That would be the beginning of life.
Thank you so much for that explanation. Yes, go ahead.
Also, the moon has demonstrated that it has a very broad spectrum of various resources that can be particularly useful in space, such as water, hydrogen, oxygen, other things that we call consumables, methane, which is a popular, increasingly popular rocket fuel, as some people may know. But also there is a light element of helium, light isotope of helium, called helium-3. And that helium-3 is an ideal fuel for fusion power reactors. And the nice thing about helium-3 is that it creates no radioactivity when fused with itself, and very, very little when it's fused with a heavy isotope of hydrogen called deuterium. And so the moon has been collecting helium-3 from the sun. It's created in the sun, comes to the moon and the Earth's atmosphere as part of the solar wind. But unfortunately for that use of helium-3, the Earth rejects it. Helium is too light for the Earth to maintain without it having impacted the surface. And on the moon, it impacts the surface and is retained.
Thank you so much for that explanation. That answers a number of our questions in terms of what are surprising things people can learn from geology and not only the history of the Earth, but then what is leading to potentially useful resources that we could leverage on the moon to further explore space. And I think that the quote, the moon is the library, is really interesting. I didn't think about it that way in terms of being able to learn so much, and it's there right now. Certainly there's so much that we don't know. A lot of young learners might not know that the gravity, yeah, please go ahead.
My mentor with the U.S. Geological Survey back in 1964 was the famous planetologist Gene Shoemaker. And one of the things that he said very early on was that we should learn to read that library of the moon, that it is a record of solar history. And that not only the early history of the Earth, but it has recorded the history of the sun. And we are just now, in the last few years, beginning to figure out how we can read that solar history. And one aspect of that is that some work I have done, particularly on what's called the deep drill core from Apollo 17, gives us information that the sun changed its energy level about 530 million years ago. And here on Earth, we have a record of an explosion of life on Earth called the Cambrian explosion, and an explosion in the diversity and the quantity of life here on Earth. And it may well be we have seen evidence of why that happened here on Earth in this deep core that we took on the moon. It's really an exciting new discovery, I think. And now, correlation is not necessarily causation, as many people will tell you through the years. But nevertheless, it is an exciting discovery that a change, an increase in the energy level of the sun may have triggered the explosion of life here on Earth that ultimately led to all the life families, all the life forms that we see today, including ourselves.
Absolutely. Absolutely fascinating. And thank you for the background on that. I mean, understanding, I think, from a geological perspective, but then also a historical perspective around how that energy change may have sparked life here on Earth, I think it's a very valuable takeaway. I think a lot of young learners may not know that the gravity is actually different on the moon than it is on the Earth. So at the moon, we have 1/6 gravity. So anybody would want to know, what is it like to live, work, and even sleep in an environment that has 1/6 of the gravity as it does on Earth?
Well, it's a great place to work and live. It's very comfortable. Human beings are basically lazy, I think, and we have to keep working very hard to get around that. And on the moon, because you're only 1/6 your weight, you're still the same mass, only 1/6 your weight. You don't have to work nearly as hard to accomplish various tasks. And if you want to imagine what it's like to run or ski, if you will, across the surface of the moon, just imagine being on an infinite. It does feel a lot like that in 1/6 Earth's gravity.
As a former ski instructor, I can relate. That sounds like a lot of fun when you're kind of gliding down. So looking at not only the differences of the gravity, I had a question for you about exploring the moon. Along with Commander Cernan, you completed 3 EVAs in the Taurus-Littrow Valley. I was curious what some of your more interesting discoveries were and why.
Well, on all 3 of these EVAs, and that stands for extravehicular activity, but every one of our EVAs had a series of discoveries. I would say maybe the most important from the first EVA, where we deployed a package of scientific experiments, and was the one I taught a few moments ago, and that is the ability now to start to read the history on that particular EVA. We visited a series of the youngest craters, sort of gave us a bookmark, if you will, on the younger craters on EVA. We not only visited the base of a high mountain called the South Massif that was more than 1,000 feet high. You can imagine that towering above you, it was quite a spectacular sight. But we were able to go to a small crater called Shorty Crater. And there I discovered this orange soil, what turned out to be a ash. And that has also begun to reveal its secrets. For example, it appears that ash had its origins as a lava initially, deep within the moon, down about 500, 550 kilometers below the surface of the moon. And it is starting to tell us not only about the interior of the moon, but also tell us some of the isotopic ratios that existed when the moon formed. Because it is coming from so deep within the moon, it has not been affected by other seas that have changed those isotopic ratios. So again, we're starting to learn about the solar system by studying this particular volcanic ash. It's probably the most noteworthy and exciting discovery that we had on that second EVA. On the third EVA, we visited the base of another massif, it's a south massif, but a very large boulder that was examined that had rolled down the side of that massif, those steep slopes. And that boulder now has given us some information, a lot of information about the age of various major impact events on the moon. I need to emphasize how large these impacts were early in the history. It's probably 3,200 kilometers in diameter. And if you can imagine that happening on the moon, called the prosolar, is happening on Earth as well. And it's conceivable that the formation of these very large basins and the melting of rocks and their crystallization after that might have provided the seeds to the first continents here on Earth. We don't know that for sure, but it is one of the, there's another basin mostly on the far side of the moon that's 2,500 kilometers. It's almost hard to imagine that you had events of that scale, explosive events of that scale, happening both on the moon and the Earth. So you can see that every EVA was a continuous train of discoveries, that all of which are still being worked on. The nice thing about bringing back rocks back from the moon and observations and photographs back from the moon, they constitute in aggregate a gift and there is a broad community of lunar and planetary scientists, several thousand, that have continued to work on these materials for the last 50 years, since Apollo 11 and Neil Armstrong brought materials back from the moon.
That's absolutely fascinating. To build on that, I was curious, in one of the EVAs, and I was curious if it was the South Massif EVA that you're referring to on the third, was that where you had collected the sample designated troctolite 76535? And if so, what made you collect that sample, and why has it been designated the most interesting sample collected from the moon?
Well, I'm not sure I would agree with that designation. And it was collected as part of what we called a rake sample, where I drug a sieve, really, we call it the rake, but a sieve through the topsoil regolith of the moon and collected fragments that were all larger than about a centimeter or two. And it was one of those fragments that came to be known as the troctolite. Previously, on the second EVA, that all happened on the third EVA. On the second EVA, I had noticed a greenish inclusion or one of the breccias. A breccia is a rock composed of other rock. As a matter of fact, I can show you one right here that is a slice of a meteorite. And this meteorite happened to be a breccia as well. And you can see that there are a number of different clasts in that breccia itself, probably rich in feldspar or plagioclase are the white ones, And the dark matrix is probably rich in olivine and other minerals, as well as glass. Glass is very common in these breccias. Now, but that particular sample, its numbers is 72415, is almost a pure olive that show very strong evidence of having also come from very deep within the moon, probably as much as 400 or 500 kilometers. And they probably came because of this very large impact event to you, the overturn of a still very soft and partially fluid mantle of the moon due to the impact. Some of the rocks that we sampled, several thousand kilometers away from that event, are rocks that were brought to the surface initially, or near the surface, by this Procellarum base forming event. Later, large impacts like the Imbrium Basin, Serenitatis Basin, Crisium, and others, then were able to extract these minerals from being in shallow level, and we were picking them up in the Valley of Tars Littrow. They're originated. What changed? What we call metamorphose. Cut as the troctolite and the dunite.
Thank you so much for sharing that. That's amazing. And thank you also for sharing the background on the sample 72415. There are so many answers that you're sharing about questions relating to the history of the Earth and the Moon and geology. And many folks wonder, does science have all the answers? And we're wondering from you, does science have all the answers? And if not, why?
Well, science is sort of a iterative affair. It has part of the answer at times. Like a good example, of course, Newton had part of the answer of what is gravity. Einstein came along and gave us even more detail into what gravity is. And that all results from people continuing to question the conclusions of the past. And that's very important. If you want to be a scientist, a good scientist, you have to continue to question your own conclusions. Don't ever assume that you're absolutely right. Keep testing those conclusions. And this is in general. Keep testing your conclusion that you're really on the right track. There's a lot in science today. People have jumped to conclusions and have wedded themselves to those conclusions and are afraid to change. Don't ever be afraid to change.
I love that. Thank you so much for that. Don't be afraid to change. Science has part of the answers. It's fantastic advice for some of our young learners. I had a couple questions for some of the adult learners who might be watching some of this content and hearing some of your answers. You have spent so much time in environments like mission control and in space, solving problems with other people and working as a team. I was wondering, what can folks learn from that environment about teamwork and working together more effectively?
You just dropped out a bit, but I think I got the question. You want to repeat it again, please?
I'd be happy to, of course. A question for some of our adult learners. There's so much that we could learn from you around working with other people as a team, both in your mission and in mission control. And mission control particularly seems to be a case study in collaboration, working with other people, solving problems, managing risk. And we're wondering, what is your advice for people looking to work more effectively as a team?
Well, the first thing you have to remember about mission control, and indeed about NASA, there were the 400 who, once they came into Apollo, they learned to work as teams. And they very quickly discovered that the sum of the knowledge of the team was less than the total knowledge of the team. And there was a synergism that came by working together and being willing to debate your conclusions or your thoughts and your and come to a not only possible solutions, plural, of course, abundantly demonstrated by Apollo 13, but it was going on in every mission. Whenever occurred, or even problems that occurred during tests of hardware and things like that, just got together almost seemingly spontaneously of young men and women who to work together as a team and be willing to debate their ideas, not to say I'm right, but to debate them and look at the details. And if you don't quite understand it, go off and gather more information about the issue. Very, very important lessons for the future.
Thank you for that. The ability to be able to debate issues and also to find common ground with disagreements. I would think as well that there were situations where a number of different solutions would be presented, and ultimately one person or a group of people need to make a decision. Often people will say, well, that's the leader. Was curious, what makes a good leader?
I think the primary thing that makes it not only background and knowledge. For Apollo, it was primarily engineering knowledge. The more science was in there, the better. But primarily it was engineering knowledge and experience. And so that you could evaluate what people were recommending based on that much broader, sometimes much broader experience. There is a discipline in engineering called systems engineering. It really is something that can't be taught. There are systems engineering courses that are offered, but it comes from experience of seeing how systems and subsystems and components work together in a variety of circumstances. We were very fortunate that the leadership of NASA at the start of Apollo had been cutting their teeth on some very complex issues related to the X-15 jet rocket plane. That into doing even more complex operations that were required for Apollo. Kranz, Chris Kraft, they were all sort of cut their teeth in those early days, not only of flight, of rocket flight, but also of aircraft flight and of the Mercury and Gemini programs. Very important to gain those kinds of experiences so that you can evaluate what people are recommending that you do.
Thank you for sharing that. It sounds like there's a thread around being able to have a deep understanding of the different systems that are at play if you're working with other folks and particularly leading those teams. Question for you around generations. Once heard you say, this is a fantastic quote. I really appreciated this passage. When you want to do great things, you depend on young people. So I was wondering, how can we empower the next generation to pave the way for the future of space exploration?
Well, we can certainly totally reform our education system. Many things are being left out of our education system, not the least of which is mathematics, but also critical thinking, just teaching how to think about a problem in all aspects of it, gather as much information as you can to solve the problem. Mathematics, of course, is very important in teaching critical thinking, but history is just as important. Language is important. All of these things have to be reformed. I'm afraid that the vast majority of our public education system has gotten well away from the kind of education in critical thinking that is going to be required and is required today for the present.
Absolutely. It's a fantastic point about not only continually educating, but also building in critical thinking skills. And I think in today's business environment, when big companies and organizations are so focused on innovation, it sometimes helps to have fewer folks and younger folks and less systems to truly be entrepreneurial.
Young people have a much stronger propensity to imagine than do those of us who get a little bit older. That was my experience in Apollo, is that you got much more imagination and innovation from 25-year-olds than you did from 30 and 40-year-olds. That's very important to remember. Just look at when most of the people who have won Nobel Prizes, it's on work that they did when they were in their 20s. That's where our brain is by far the most productive as human beings. And we just need to remember that when you want to take on problems such as a landing on the moon or taking care of conflicts here on Earth, who do we turn to? We turn to the young people to do it.
It's so true. I couldn't say it better. A question for the younger generation as we look to conclude. You mentioned that Jane Shoemaker, said about the moon. It's the library of the moon, and we need to read the solar history of the moon. As we look to make decisions around space exploration, around going to the moon, going to Mars, why is the moon the ideal training ground for future missions to Mars?
Well, first of all, we have to train new generations to be able to manage the risks of space. Those risks have never disappeared. They have to be managed. Technology gives us new tools by which we can manage those risks, but often technology also adds risk. For people to think that space flight is ever going to be safe, they're just not looking at the facts. The risks are there. Safety is not the primary thing. Managing those risks is the primary thing. And that's true of life in general. There's very little that I can think of in life that can be done without some risk, physical or mental. And you have to be willing to work out, how do I manage those risks so that I can accomplish great things or accomplish my daily activities. We get in a car, for example, which is full of its own risks, as well as the fact that it's interacting with other cars, other automobiles. But we're more willing to do that because we have come to the conclusion, whether spoken or not, that we can manage the risks that are out there. Well, that's true of all of life. You just have to make sure that you understand that and that you're making those decisions that allow you to manage risks.
Thank you for that. So making decisions so that you can manage the risks. Amazing advice. If you think about the future of space missions, you're someone who's lived, in space and in the world of space exploration through the creation of these programs. What's your hope for the future of missions in space?
Well, I think at some point, either the current youngest generation or the next one is actually going to go to Mars and explore Mars. That's going to be an extraordinarily exciting place because, again, Mars is sort of intermediate between the moon and the Earth, and it's going to tell us more about the early history and particularly about the origins of life. I wouldn't be a bit surprised if we find horizons geological horizons in Mars that contain the clays that have begun the organization of complex molecules. We know the clays are there. It's just a question of what we find when we're actually able to sample them and to analyze them. But to do that, for this the next, to go to Mars, they're going to, I think, be very dependent on the moon. Much less complicated, much less expensive and the oxygen, methane, you name it, the types of things that you need in order to space mission that would take you to Mars, and then provide the fusion propulsion systems that will allow you to accelerate going to Mars and then decelerate as you get closer and shorten the amount of time that you'd be exposed to space radiation, other risks that are out there. Again, that's a way of managing the risk of deep space flight, is to go there faster and be able to come back faster. That's going to be, I think, very important. And the moon provides the foundation for doing that. Not only the foundation of resources, but again, gathering that operational experience, that very broad systems engineering, if you will, experience of what it takes in order to operate in deep space. Indeed, the moon is deep space. It just happens to be only about 3 days away.
Thank you so much for that distinction that the moon is deep space. I think we don't think of that, but you're right, because it is so close. And as we think of providing a message to the students in the Cosmosphere's Lunar Trek Camp who are watching this at their day in camp right now, and there are students who are saying to themselves, I want to walk on the moon one day, just like Dr. Schmitt. What is your advice for those watching today that want to literally follow in your footsteps?
Well, my advice hasn't changed. Get absolutely the best education you can to make sure that their kids get the best education that's available. Whatever it takes to do that, stay involved in your community to make sure that the education system that you pick is doing absolutely the best that can be done for the children. All of this happen.
Keep getting educated, get the best education you can possible. It's fantastic advice, and thank you. And on behalf of the Cosmosphere, Dr. Schmitt, thank you so much for your time and your generosity. It's been a real honor to spend the time with you.
Well, thank you so much for the invitation, and I hope that and just remember, never stop learning.